Hey there, Tensor Talkers. Back again for another Talk Tensors deep dive. Today we're looking at neurosymbolic AI. It's a field that's getting a lot of buzz lately.
Yeah, it really seems to be heating up.
And we'd love to go where the action is. So we got a paper sent to us that seemed like a perfect starting point. Neurosymbolic AI in 2024. A systematic review by Cole, Elo, and Regley from last year.
Great paper.
Yeah. Now, before we jump in, can you give us a quick breakdown of what a systematic review actually is, for those who might not be familiar with the format?
So a systematic review, it's like a super-powered literature search. Not just reading a bunch of papers, but like really systematically analyzing a whole field of research.
Okay, so it's like taking a really, really deep dive.
Exactly. They have to follow a strict protocol, to make sure there's no bias, and they end up with the most relevant, high-quality studies. This particular paper used the PRISMA method, which is like the gold standard for this type of review.
So the really rigorous process.
Oh, yeah. They started with over 1,400 potential papers and narrowed it down to 167 that actually met their criteria.
That's wild. So it's like a super concentrated distillation of the most important research in the field. Okay, so why neurosymbolic AI? Why is this systematic review so important right now?
Well, neurosymbolic AI, it's all about trying to bridge this gap we have between two really big approaches to AI. You've got the symbolic approach, which uses logic and rules to represent knowledge. And then you have subsymbolic AI, like deep learning, which is great at finding patterns in data.
Right, so it's like trying to get the best of both worlds.
Yeah. And this paper is more than just a summary. It's like a roadmap. It shows us where the field is going, what the key research areas are, what's hot, and what gaps need to be filled.
Okay, I love a good roadmap. So let's unpack those key research areas. The paper breaks down neurosymbolic AI research into 5 main categories, right?
Right. The first is knowledge representation, which is all about how we encode knowledge so an AI system can understand and reason with it. Then there's learning and inference, focusing on how these systems learn from data and make predictions.
Okay, that makes sense. So how do those two connect?
Well, you need to be able to represent knowledge in a way that makes learning and inference possible. Then you have logic and reasoning, where we try to bring in logical rules and deductions into that learning process.
Okay, so we're building up the complexity here.
Yeah.
Now, the last 2 categories sound a little more, futuristic. Explainability and trustworthiness. And then there's metacognition.
Yeah, those are the areas where things get really interesting. Explainability and trustworthiness, that's all about making sure our AI systems can explain their decisions in a way that humans can understand.
Right, because a black box AI that we don't understand is not really that helpful, especially if we want to use it in important areas like healthcare or finance.
Exactly. And then there's metacognition. That's like the holy grail. It's about building systems that can think about their own thinking.
Okay, hold on. Think about their own thinking. That sounds like something straight out of a sci-fi movie. Can you explain that a little bit more? Why is that such a big deal?
Imagine an AI system that not only learns and solves problems, but can actually monitor its own progress. Recognize its limitations and even adjust its own strategies to get better.
So it's like giving AI a dose of self-awareness.
Exactly. And that is super important for building AI systems that are more autonomous and reliable.
Okay, yeah, I can see why that would be a game changer. But let's bring it back to the paper. What did the authors find in their review of these 5 research areas? Was there a particular hotspot?
So they found a lot of activity in learning and inference, which makes sense with how popular deep learning is. Knowledge representation and logic and reasoning were also getting a lot of attention.
So far, so good. What about the more futuristic stuff?
Well, and here's the thing. They discovered this significant gap in research on explainability and trustworthiness.
So we've got AI that's getting really good at solving problems.
Yeah.
But we still don't fully understand how it's doing it.
Pretty much. And that's a problem if we want to use AI in areas where trust is essential, like healthcare or finance.
Yeah, that makes sense.
Yeah.
And what about metacognition?
Even less explored. Only a few studies are really trying to build AI systems that can actually think about their own thinking.
I guess it's still early days for that kind of thing.
Yeah, it's really challenging, technically. And it raises a ton of philosophical and ethical questions. We're talking about moving beyond just mimicking human thought to potentially going beyond it.
Okay, starting to see why this paper is such a big deal. It's not just a summary, it's like a call to action highlighting where we need to focus if we want to build AI that's not just powerful, but also trustworthy.
Exactly. We need AI that we can understand and rely on.
Now, the paper also gives some specific examples of neurosymbolic AI in action, right? Were there any projects that really stood out?
Yeah, there was one that really caught my eye, AlphaGeometry, a system developed by Google. It can solve those really complex geometry problems you see in like mass Olympiads.
Wait, so you're telling me AI can now beat high school math geniuses at their own game?
Not just beat them, it can actually discover new theorems and generate its own solutions. It's a perfect example of how neurosymbolic AI can bring together symbolic reasoning and deep learning to do something really remarkable.
Now that is what I call a novel notion. Sounds like alpha geometry could be a total game changer, not just for mathematics, but for any field that uses complex reasoning and problem solving.
Definitely has the potential.
Okay, so we've covered a lot of ground in this first part of our deep dive. We looked at what systematic reviews are, why neurosymbolic AI is so hot right now, and even got a glimpse of the mind-blowing potential of systems like alpha geometry.
A lot to unpack.
In our next segment, we'll go deeper into the paper's findings and explore how neurosymbolic AI might just be the key to avoiding another AI winter. You know, those periods where progress stalls and funding dries up?
It's a fascinating history.
Yeah, we'll dig into all of that next time.
Yeah.
So stay tuned, Tensor Talkers.
Welcome back to our deep dive into neurosymbolic AI.
You know, I'm still wrapping my head around the idea of AI discovering new math theorems.
It's kind of freaky. It really is. Like, where does that leave us humans?
Exactly. But before we spiral into an existential crisis, let's get back to the paper. You mentioned it talks about the history of AI. What can we learn from the past that might help us with neurosymbolic AI?
Well, the authors point out this pattern of AI summers and AI winters that the field has gone through,
AI summers and winters. Sounds more like a fashion trend than a research field.
Right. But it's a good analogy. These cycles are all about periods of crazy excitement and funding, followed by periods of disillusionment and, cuts.
So it's like a roller coaster ride of hype and disappointment.
Exactly. We've had two big AI summers so far. The first was back in the 50s and 60s, fueled by early successes in symbolic AI, like game-playing programs and early natural language processing.
Right. And what happened? Why did the winter come?
Well, the limitations of those early systems became pretty clear pretty quickly. They just couldn't live up to the hype. Led to the first AI winter in the 70s.
Okay, so what about the second AI summer?
That was in the 80s and early 90s, driven by expert systems. Those were rule-based systems that could kind of mimic human expertise in specific areas.
So like specialized AI.
Yeah, but again, these systems were brittle, hard to scale, led to another AI winter in the late 90s, early 2000s.
And now it seems like we're in the middle of a third AI summer.
Right.
With deep learning and all that. But could this just be another one of those hype cycles?
That's the big question. The authors of this paper think that neurosymbolic AI might be the key to breaking this cycle.
How so? What makes neurosymbolic AI different?
Well, one of the big criticisms of deep learning is that it's a black box. We don't really understand how it gets its answers, which makes it hard to trust in important situations.
Right, like we were talking about earlier with explainability and trust.
Exactly. And this lack of transparency could totally lead to another AI winter. If people lose trust in AI because they don't get it, the funding dries up and progress stalls.
So neurosymbolic AI, with its focus on logic and reasoning, could help make AI more transparent and understandable.
That's the idea. By combining the power of deep learning with the explainability of symbolic AI, we can build systems that are both smart and trustworthy.
It's like building a bridge between the intuitive mind of a deep learning system and the logical step-by-step reasoning of a human expert.
Right. Yeah. If we can get those two approaches to work together, we might finally unlock the full potential of AI.
Okay, that makes sense. But there's another thing that's always bugged me about AI. It seems like we're always focused on building AI that's good at very specific tasks, like playing chess or translating languages. But what about general intelligence? AI that can learn and adapt to any situation.
That's a great point, and the authors actually touch on that. The history of AI has been very focused on narrow task-specific intelligence.
Like training a dog to do a specific trick. It's great at that trick, but it doesn't really understand what's going on.
Right, so the question is, can neurosymbolic AI help us build more general-purpose AI? AI that can understand abstract concepts, reason about cause and effect, and make decisions in complex, real-world situations.
Now, that would be a real game changer. But let's be real for a second. There must be some serious hurdles to overcome before we get to that level of AI.
Of course. One of the biggest challenges is figuring out how to represent knowledge in a way that's both expressive and computationally efficient.
What do you mean by expressive?
We need a way to represent knowledge that captures not just facts, but relationships, hierarchies, logical inferences. Like, think about how much information is packed into a simple sentence, like, the cat sat on the mat.
Okay.
We know a cat is a type of animal, that sitting is an action, that a mat is a surface. We can also guess that the cat is probably smaller than the mat, that the mat is on the floor, and so on.
Wow, I never thought of it like that. It's amazing how much we just assume in our everyday understanding of the world.
Exactly, and that's just a simple sentence. Imagine trying to represent all of human knowledge in a way that an AI system can understand and use. It's a massive task.
So we need a knowledge representation system that's not just comprehensive, but also flexible enough to handle new information and adapt to change. No pressure. AI researchers, what other big challenges are there for neurosymbolic AI?
Another one is figuring out how to integrate symbolic reasoning with deep learning in a way that's seamless and efficient. These two approaches have different strengths and weaknesses. Deep learning is great at pattern recognition, but struggles with logic. Symbolic AI is great for logic, but can be slow and clunky with huge data sets.
It's like trying to merge two companies with totally different cultures.
Right.
You've got the freewheeling, data-driven deep learners on one side and the structured, rule-following symbolic AI folks on the other. Getting them to work together is going to be interesting.
Exactly. Researchers are trying different things, like hybrid systems that combine elements of both approaches and new algorithms that can translate between symbolic and sub-symbolic representations.
So it's not just about building better AI systems, it's about finding a common language that lets different types of AI talk to each other and work together.
That's a great way to put it. And that's where it gets really exciting. If we can make neurosymbolic integration work, we could unlock a whole new level of AI. Imagine AI that can not only learn from data, but reason about it, make logical inferences, and explain its decisions so we can understand.
Okay, I'm officially on board the neurosymbolic AI hype train. But before we get carried away with all the possibilities, we should probably talk about the ethics of all this.
Right,
Okay.
absolutely. As we build more sophisticated and independent robots, we have to make sure they're aligned with human values, that they're used for good, not for bad stuff. We also need to think about who's responsible if something goes wrong, transparency, and the potential impact on society as a whole.
So it's not just about building smarter AI, it's about building AI that benefits humanity and reflects our values.
Couldn't have said it better myself. We need to keep those ethical questions front and center as we push the limits of what AI can do.
Okay, so we've covered the history, the potential impact, and the ethics. But I'm still curious about those novel notions you mentioned earlier.
Right.
You know, those out there but maybe not so crazy research ideas. Let's take a break and come back to explore some of those cutting-edge ideas in the next segment.
Sounds good to me. Looking forward to it.
Okay, so my neural networks are all fired up and ready for some novel notions. You know, those kind of out there research ideas that pop into your head when you're deep in a paper like this.
I'm with you. Let's see what we can come up with.
So we talked about how neurosymbolic AI could make systems more explainable and trustworthy. Even touched on metacognition AI that can think about its own thinking. But what's next? What are some really novel research directions that could push the boundaries even further?
Well, one area that I find super interesting is the intersection of neurosymbolic AI and embodied cognition.
Embodied cognition.
Right.
Okay, now you're going to have to explain that one. What does that even mean when we're talking about AI?
It's the idea that our minds aren't just these separate information processors, floating around. They're connected to our bodies and how we interact with the world. Our senses, our movements, our experiences, they all shape the way we think and learn.
So you're saying that to build truly intelligent AI, we can't just focus on algorithms and data. We need to think about how AI interacts with the physical world, how it senses acts and learns from its experiences.
Exactly. And that's where neurosymbolic AI could be huge. Imagine robots with neurosymbolic systems that can perceive and act in the world, but also reason about their actions, understand the consequences, and adapt to new situations.
Okay, I'm starting to see the potential here. It's like taking those self-driving cars we talked about and going way beyond that. Instead of just navigating roads, we could have robots doing complex tasks in factories, hospitals, even our homes.
Right. And these robots wouldn't just be following pre-programmed instructions. They'd be able to learn from their experiences, adapt to new stuff, and even collaborate with humans in a more natural way.
That's both amazing and kind of scary. Designing robots that can integrate perception, action, and symbolic reasoning, that's a huge challenge.
It is. It would take breakthroughs in areas like computer vision, robotics, natural language processing, and of course, neurosymbolic AI itself.
So where do we even start? What kind of research could help us bridge the gap between AI as we know it and embodied cognition?
One way is to develop new neurosymbolic architectures specifically for these embodied agents, architectures that can handle both symbolic knowledge, like rules and concepts and sensory data from the real world.
So like building a brain for a robot that can process abstract ideas and concrete experiences.
Exactly. We also need new learning algorithms that let these agents learn from interacting with the world. Things like reinforcement learning, imitation learning, even developmental robotics, which takes inspiration from how children learn.
It's like raising a robot child. You don't just program it with everything it needs. You give it the tools and the environment to learn and grow on its own.
That's a great way to think about it.
Yeah.
It's about creating AI that can learn and adapt in the real world, just like we do.
This is all pretty mind-blowing. But before we get too carried away with visions of super intelligent robots taking over, we should talk about the ethics.
Right, definitely. As we create more advanced robots that can act on their own, we need to make sure they're aligned with human values, that they're used for good, not for harm. We also need to think about accountability, transparency, and how this will affect society.
So it's not just about building smarter AI, it's about building AI that's good for humanity and reflects what we believe in.
Absolutely. We can't forget about those ethical considerations as we keep pushing the boundaries of AI.
Okay, so we've explored embodied AI and the ethics. But before we wrap up this novel notions segment, I have one more thought. We talked about robots interacting with the physical world. What about AI systems that interact with and even influence the digital world?
Interesting. We've already got AI like ChatGPT generating text images, even code. What if we had neurosymbolic systems that could not only create digital stuff, but understand its meaning, reason about its impact, and even act on it?
Hold on, you're saying we could have AI that's like digital architects shaping the online world based on their own goals and values. It's like giving AI the keys to the internet.
It's a pretty bold idea, but think about it. AI that could monitor social media and flag harmful content or misinformation, and then take steps to stop it from spreading. Or AI that could analyze financial data, find market trends, and make investment decisions.
Wow. Now you're talking about AI that could have a huge impact on our economy, our society, even our democracy. The benefits could be amazing, but the risks are huge too. We'd have to be super careful about how we design and use these systems.
Absolutely. This is all still pretty speculative, and there are tons of technical and ethical challenges. But it's a fascinating idea that shows how neurosymbolic AI could not just understand the world, but actually shape it.
Well, there you have it, folks. We've explored the amazing world of neurosymbolic AI, from its history and key research trends to some mind-blowing novel notions. This field is full of potential, and I can't wait to see what the future holds.
Me too. It's a field that's ready for big discoveries. I'm sure we'll see incredible breakthroughs in the coming years. And who knows, maybe some of our novel notions will inspire the next wave of AI researchers.
And on that note, we'll wrap up this deep dive into neurosymbolic AI. Check out the show notes for a link to the paper if you want to learn more. And as always, thanks for tuning in to Talk Tensors, where we brew up the strongest AI insights.
Until next time, keep those neural networks firing and those symbolic engines running.